Yeah, so this one, the voltage. Okay, so this requires you to know something about the period and the range of a trigonometric function, and then kind of how that is affected by transformations. Sort of a tricky way of asking it because they didn't give you the period and the range. So, if we have sine theta, just plain old sine theta, the period is 360 degrees, and the range, we'll just go with R, the range is -1 to 1. Yeah? And then if you go to like 2 theta, that would make the period half. So that would be 180 degrees. And the range is unaffected. It would just be -1 to 1. And then the other thing you can do is have like 6 sine theta. And that would make the period 360 degrees. And the range would be -6 to 6. Yeah? So if you, if you multiply your angle by a number there, then you divide your period by that number. So by doubling the number, like instead of theta, 2 theta, that caused this to half. And then basically whatever the coefficient is, so whatever's here, so in that case that is a 1, which is why the range is -1 to 1. Again, here it's a 1, so the range is -1 to 1. Here it's a 6, so the range is -6 to 6. Yeah? So you kind of use that theory. Essentially what we have here is it's 120 pi times t. So the variable has been multiplied by 120 pi. So we take our, the fact that it has a pi means it's radians. So instead of 360, we use the radians version, which is 2 pi. So the period should be 2 pi. We divide it by whatever the angle has been multiplied by. So we divide it by 120 pi. They cancel, and that gives us 1/60. So that's why people were getting zeros when they did it. You were never going to guess that. Like, you were never going to guess that the domain was like 1/60. Like, that's, I don't even know what that number is. 0.016 recurring. Most of you are putting in number 1, 2, 3, 4, which is why it wasn't working. And the range then, just like I did on the other side, basically whatever's there in the orange is the range. So it's going to go from -110 root 2 up to 110 root 2. Again, I don't even know what those numbers are. 110 root 2 apparently is 155.6. So from -155.6 to plus 155.6. Yeah? Okay, sketch the function between 0 and p. Okay, so we now know that p is 1/60. Indicate the period in the range of the function on your graph. They didn't even give me a... Anyway. Okay, so I'm going to try this again. I'm going to put in radians. And I'm going to go into my function, so my table thing. I'm going to go 110 root 2 sine 120 shift pi alpha x. Yeah. Skip over g of x. I'm going to start at 0 and then I'm going to end at 1/60. Okay, that seems to be working. Sorry, I know exactly what I did there. I went up in steps of 1, which isn't going to work. Sorry, equals. I want to go up in steps of, I don't know, between 0 and 1/60. How do I break up 1 over 60 into something resembling a domain? Sorry, bear with me. 1 over 60 I said was... So can I split it up into like... I don't know. It's 1 over 60... Okay, so if I do 1 over 60 minus 0 and divide it by like 10, so I get 10 intervals. This is hard. So basically what I did was I subtracted them and then I divided it by 10 to split it up into 10 intervals. So that is steps of 1 over 600. Right, I'm going to try again. 110 root 2 out. Sine 120 pi x, close that. G of x I put nothing in. I want to start on 0. I want to end at 1 over 60. And I want to go up in steps of 1 over 600. Oh, okay. Well, I have numbers now, so that's good. Sketch the function. Okay. So, I mean, it is just a sketch, and they didn't give us any graph to kind of work off. I know my max value is going to be the 110, whatever that is. So 1, 2, 3, like 110 root 2. And 1, 2, 3, 4 is minus 110 root 2, which I think I said was like 155, didn't I? And then I'm after going up in like 1 over 600. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. That should work. So it tells me 0 is 0, and then 1 over 600 apparently is 91. So if that's 150, half 150 is what? I can't even do that anymore. 75, so it's going to be like here somewhere. And then the next one is 147, so it's going to be quite high. But there. Next one is also 147, which is there. Max value must be in between those somewhere, which is annoying. 91 then. Are we back to 91? Yeah, we're back to 91. Which is like there. And then back to 0. Then we should go negative. We do, thankfully. So that's like, should be over this. It's about there. Then minus 147. So again, very close to the end. Another one of them there. Minus 91, which looks like it should, and yeah, actually worked. So this is what it looks like, which is like, as in, sorry, that's terrible, but this is what we would expect. Like it should look like a sine graph. So this is 1 over 60, so I've made the period clear, and I've made the range clear because I've got 110 root 2. Sorry, I'm checking this with the solutions, which I found. Yeah, so actually I'm way more detailed than they wanted, but yeah. It's a sine graph basically between 0 and 1 over 60, and then going down to minus 110 root 2 and up to 110 root 2. That was tricky. Okay. Use VT to find the voltage when T is 6.67. So that is 110 root 2 sine, pi and then T. So pi and then 6.67. Is that right? 100. Oh, I just didn't write the 120. 120 pi T. Okay. So 120 pi 6.67. Yeah. Right, I'm going to make sure I'm in radians again. I'll put that back. Make sure I'm in radians. So that's 2. Okay, so 120 by 6.67 by pi is that. I'm going to get the sine of that, which is that. I'm going to multiply it by 110 root 2. So I am getting to 2 decimal places, 147.95, which is right. That was a lot easier. And find one value of T. Find one value of T where the voltage is 110 volts. Okay, so that's where I have the answer. So it's like 110 equals 110 root 2 sine of 120 pi T. Like this feels, it's going to be the same again. What's it called? The trigonometric equations. So 0.707, it goes on, equals the sine of 120 pi T. Okay, so again, just this and this. I'm going to go back into degrees. So inverse sine of 0.707. Oh, it's 45 degrees, almost exactly. So I get my circle, CAST. Sorry, I'm just going to try that again. I'm going to inverse sine that with the full, yeah, it is 45. Sorry, that number is not finished, it goes on, that 0.707, and if you leave the whole number in, it is exactly 45 degrees. Okay, so where's sine positive? That's here. So I'm going to put my 45 degrees here and here. So that's 45 there and 45 there. This one is actually 45 degrees and this one is 180 minus 45. So it's 135 degrees. Okay, again, if there was nothing in here, I would be done. But that is not the case. So I have 120 pi T equals 45 degrees. Find one value, and then 120 pi T equals 135 degrees. Okay, so again, you have to convert one of them. It really doesn't matter. This is actually not hard to convert this time because aren't they the ones in the formula and tables book, so they're already converted? Are they special angles? I think they are. 135 isn't, but 45 is. So 45 is pi over 4. So pi over 4 equals 120 pi T. Divide by 120 pi, divide by 120 pi, cancel, cancel. So T is, now I'm going to put that over 1 and I'm going to KFC. Sorry. 1 over 120 pi. So that gives me pi over 480 pi, and then the pi's cancel. So T is 1 over 480. Like that's one value. If I want to go and do the other one, there's no reason to, but if I want to, 180 degrees equals pi. I want 135. So go back to 1. So divide by 180 and multiply by 135. Divide by 180 and multiply by 135. So pi divided by 180 multiplied by 135 is 3 pi over 4. so I can use that. So 120 pi t equals 3 pi over 4. Divide by 120 pi to cancel, divide by 120 pi. So t is 3 pi over 4 over 1, so multiplied by 1 over 120 pi. That is 3 pi over, what was that, 480? Pi, they cancel. 3 divided by 480 is 1 over 160. They're time, aren't they? They only wanted one, so I assume either of them will do. Yeah, so like that one was grand. That one was grand. Those two were tricky. I might look at the marks for those two, because those two were tricky. I have actually found the scheme for these, so these are all right, I think. Let me just double check the airplane one. Not that one. The airplane, question 5. So 1.5 hours was the first one. Yeah. 1 hour and 30 minutes. Said correction, the nearest minute. So 1 hour, 30 minutes or 90 minutes is correct. The next one then, what did I say? Yeah, so 2, an hour and a half, and 3.45 hours, which is grand. So it's 6.95 hours. And yeah, they use slightly different decimals, but they're around 95,000, which is what we got, so less than 100,000. And this one, like I said, it's tricky, but anyway, you know how to do it now. It's only worth 5 marks actually, so I'd say everybody found it tricky, and so is this. So yeah, again, everybody found that tricky, but anyway, that's them. This was grand, substitution, and this was just a trigonometric equation, so I would, like everything, not easy, but I would hope you'd be able to do it. Yeah, okay, so that's it. In I don't know how many parts, but that's it.